Hi, my name is Sadlin Nabila binti Muhammad Isman, and my matrix number is 206389. So the first question is, the company needs to design a cylindrical that can hold 475 cubic centimeter of fluid. What are the dimensions of the can that would require the least amount of materials? So first of all, you need to define the variables used in the problem and organize the information using a picture. So we draw a picture of a cylindrical can and then list the variable that have, which is r equal to radius and h equal to height. And then we list the constraints, which is based on the questions they stated the volume. So the volume for cylindrical can is pi r squared h, which is equal to 475 centimeter cube. Second, list the objective function. The objective function is the function that we want to solve, which is the dimensions of the can, which includes surface area equal to area of the top and the bottom plus area of the outside, which is equal to A equal to 2 pi r squared plus 2 pi rh. Then next step, we write the objective function in terms of one variables and use the constraints to eliminate all but one variable of the objective function. For this, we choose h, so we bring all the other variables to the right. So h equal to 475 over pi r squared. And then we sub into the function like this. And we get a equal to 2 pi r squared plus 950 over r. Then we use calculus to find the maximum or minimum value of the objective function. So we differentiate, which is the a over dr equal to 4 pi r minus 950 over r squared, which equal to 0. And to minimize AR, we need to take the derivative of AR and find the critical values. Remember to find the critical values, and we set the derivative equal to 0, like this. Then we find the R. So next step, by using the second derivative, we find the value which is minimum or maximum. This is the second derivative of the function, and then we sub r into the function, and then we find that the second derivative is bigger than 0. If the value is bigger than 0, it is minimum. So then we get r equal to 4.23 centimeter. And this value we sub back into this h, which is equal to 8.46 centimeter approximately. So the dimension that will minimize the material use are when the radius is 4.23 centimeter and the height is 8.46 centimeter. And that's all.
Assalamualaikum warahmatullahi wabarakatuh. So, my name is Halimatul Sa'dia binti Mustafa. My matric number is 207897. Okay, I just choose question number 3. The question is, a rectangle is constructed with its base on the diameter of a semicircle with radius of 6 feet and its two other vertices on the semicircle. What are the dimensions of the rectangle with the maximum area? So, first of all, I draw the x-axis and also y-axis. and draw the semicircle, which is the radius is 6. It's mentioned in the questions. After that, in the semicircle, I draw the rectangle and make the height is y and also the base is x. So as we know, the area of the rectangle is L times with the W, and we gain the 2x times with y. Y is 2x. It is because at the base here, at the negative side and the positive side, so we gain the 2x. X plus x, which is 2x. And after that, we do the theorem Pythagoras theorem, okay, which is x squared plus y squared equal to 6 squared. Why it is a 6? It is because, as we know, at any point of the circle, at any point radius of the circle, it will be the same. So it equal to 6, and we get the y is equal to square root 36 minus x squared. Okay, actually, why we must to do the Pythagoras theorem? So that it will be easier to us to find, for example, to find the first derivative. We also can find the subject, which is y, but I choose to be y, and I will substitute it in the x equal to 2xy. So I will substitute it y in that formula. After that, we find the first derivative. We use the product rule. So we find the u prime, and also v and v prime, and we gain the first derivative is negative 4x squared plus 72 over by square root 36 minus x squared. And after that, we must to the first derivative, we must to equal to 0 to find the x value. And we gain the x value, which is, we gain the 2x value, which is 3 square root 2, and also negative 3 square root 2. After that, we do the second derivative. Why we do the second derivative? It is because in the equations, it sets at a maximum area. So, which one x that we want to choose, whether the positive one or the negative one. So we do the second derivative by the quotient rule. After that, we gain the second derivative is 4x times with x squared minus 54 over by 36 minus x squared to the power of 3 over 2. Okay, and after that, the value of the c, which is the value the value of x at the first derivative, we put it in the value of the x in the second derivative, and we gain for the positive 3 square root 2, which is negative 8, less than 0, and for the negative 3 square root 2, which is 8 more than 0. As we know, when the functions less than 0, that function have a maximum at that point. So we gain that 3 square root 2. We gain that the functions, the second derivative of the function 3 square root 2 is less than 0. So the relative maximum is equal to 3 square root of 2. So we choose the x is 3 square root 2. And after that, we substitute the 3 square root 2 to the equations y is equal to square root 36 minus x squared. It is because we want to find the width of the rectangles. So we gain the rectangles of width is 3 square root of 2, and next we find the length of the rectangle. So the length is 2x, and the maximum length we substitute the x value. So 2 times with 3 to the square root of 2, and we gain the 6 square root of 2 feet. So the dimensions is we get the maximum length is 6 square root of 2 feet, and maximum width is 3 square root of 2 feet. That's all. Thank you.
Hello and Assalamualaikum everyone. So I'm going to do the question number 6 for SAL. So the question is, we want to construct a box whose base length is 3 times the base width. The material used to build the top and bottom costs $11 per square foot, and the material used to build the sides costs $7 per square foot. If the box must have a volume of 75 cubic feet, determine the dimensions that will minimize the cost to build the box. Okay, so first kita lukis the cube. Okay, kita dapatkan h equals to height equals to h for height, and w for width and l for length. So kita akan dapat kat sini length equal to 3w because it is 3 times the base width. Okay, hello. So first kita kena dapatkan equation pertama, volume of box v equals to l times w times h equals, maksudnya length times width times height, dan kita masukkan semua nilai dia ke dalam equation ni, dan kita akan dapat 75 equals to 3w square h. Equation pertama. So next equation is cost of box C equals to 2 times area of top or bottom times 11 plus 2 times area of front or back times 7 plus 2 times area of sides times 7. So kita masukkan semua equation kat dalam tu, dan kita akan dapat equation kedua, which is 66w square plus 56wh. From 1 we get equation 3, which is 75 equals to 3w square h. Kita dapatkan h equals to 75 over 3w square. Next, kita put equation 3 into 2. So c equals to 66w square plus 56w, and dalam h tu kita masukkan equation ketiga, 75 over 3w square. And bila kita simplifykan equation ni, kita akan dapat 66w square plus 1400 over w. So untuk dapatkan minimum cost, we need to find critical point of C, which is C prime, and kita dapat kat sini, bila kita dah dapatkan C prime, kita akan dapat 132 w cube minus 1400 over w square. Bila kita dah dapat C prime, kita boleh masukkan nilai W. Kita akan pilih nilai W. So bila kita pilih nilai W 0, kita akan dapat jawapan undefined. Tapi kita pergi ke nilai yang seterusnya, iaitu W equals to 2, kita akan dapat first nilai kita akan dapat negatif, dan bila kita letak 3 for W, kita akan dapat nilai dia positif. So kita akan ambil W equals to 2.198 is an absolute minimum. So kita akan masukkan absolute minimum ke C yang kat atas ni, dan kita akan dapat jawapan $955.80. Okay, that's all.
Assalamualaikum. I will explain about question 4. Firstly, we must define the variable used in the problem and organize the information using a picture, length, width and height. And next, we must list the constraint. L plus W plus H equal to 120 to X plus Y equal to 120. Then next, list the objective function, which is V equal to L multiplied by W and H v equal to x squared y. Write the objective function in terms of one variable. Use the constraint to eliminate all but one variable of the objective function, as I list down below. And then next, use calculus to find the maximum or minimum value of the objective function. Maximize Vx and find the critical number, which is x equal to 0 and x equal to 40. Use the first derivative test to determine if each critical value is a maximum, minimum, or either. X equal to 40 is a maximum because the derivative change from positive to 0 to negative. And then we get the answer, which is x equal to 40, y equal to 120, minus 22 multiplied by 40, and then equal to 40. The dimension that will produce the largest area are length equal to 40 inches, width 40 inches, and height equal to 40 inches. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Syuhada binti Muhammad Zainuddin, and I will continue our presentation with question number 5. What point on the line 3x minus y equal to 4 is closest to the point A, negative 2, 3? Since 3x minus y is equal to 4, so we rearrange the equation to get y equal to 3x minus 4. We take this point B on the line that can be expressed as x 3x minus 4. We want to minimize the distance from point A, negative 2, 3 to point B. To calculate this, we need to use the distance formula to calculate it. So we substitute the value that we already have here, which is negative 2, 3, in this distance formula, and we got 10x squared minus 38x plus 53. It is enough to minimize function 10x squared minus 38x plus 53. To minimize the function, we take the derivative of the function and set it equal to 0. So when we derive the function here, we get 20x minus 38. So when we equal it to 0, we get x equal to 19 over 10 as a critical point. To know whether the derivative of fx is greater than 0 or less than 0, we substitute it in the function here that we get from the distance, and we know that function f is decreasing when x is less than 19 over 10. Then we try again by using the same method, but to know if the derivative of function x is greater than 0. So we know that function x is increasing when x is greater than 19 over 10. So if we want to know whether it is greater or not, we need to use this and substitute it with other value that greater or lower than the critical point that we already get from here. Therefore, we get that fx, the function x, is minimized when x equal to 19 over 10. To get the point B, which is closest to the point A, we substitute back the value of x that we get here in the point B that we express as the below, which is b equal to x 3x minus 4. Then we get the final answer is 19 over 10, 17 over 10. So this is the point B, which is the closest to the point A. All right, thank you.
Assalamualaikum and very good day to everyone. My name is Nashrik bin Naim. My metric number is 206993, and today I will be explaining the SCL task 1, Calculus MTH3100 for question number 7. So at which point on the curve y equal to 1 plus 40x to the power of 3 minus 3x to the power of 5 does the tangent line have the largest slope? So the first step that we need to do is to differentiate the slope of tangent. After we differentiate it, we will be getting 120x squared square minus 15x to the power of 4. So we will denote the slope tangent as Sx. So this is the equation that we will be denoting. So we will be finding the value of x for which Sx is maximum. So we differentiate it and we will be getting 240x minus 60x to the power of 3. So the second step that we need to do is solve for Sx equal to 0. After that, we will be dividing both sides by 60. So we will get 4x minus x to the power of 3 to get the after we factorize it. So we will be multiplying by -1 to make the negative sign for the unknown to be positive. And then we will be getting 3 critical number, which is x equal to -2, 0, and 2. So there are 3 critical number that we will be getting. For step 3, again, we differentiate to get 240 minus 180x square. So we evaluate the equation for 3 critical number, which is -2, 0, and 2. And we'll be getting 3 different answer, which is the first and the third one will be the same answer. So the Sx is negative and x equal to positive and -2. Hence, there are there is a local maxima at x equal to positive and -2. So for the fourth step, we will be concluding our answer. So the local maxima is absolute maxima because limit x approaches positive and negative infinity, we will be getting positive and negative infinity. Hence, the slope is maximum when x equal to positive and -2. So we will be getting the y coordinate of the point by substituting x equal to positive and -2 into the equation y equal to 1 plus 40x to the power of 3 minus 3x to the power of 5. And we will be getting 2 points, which are 2 and 225. And another point is -2 and -233. So the slope is maximum at these 2 points, which is 2 and 225 and -2 and -233. So this is the graph that if we plot it, we'll be getting this kind of graph, which is the negative side and the positive side. So that's all for me. Thank you.